Alright, so in this video we're going to be going over IDAPython scripting. This is my Twitter if you guys have any questions, and I'm trying to plug my forum site that I made like 4 or 5 months ago that like nobody uses. But we do have a few good members on there and some good content. But if you would like to discuss anything in this video, you're more than welcome to go to malwareanalysisforums.com and ask questions, as well as hit me up on Twitter. All right. So the biggest question, most important question in my mind is always why. Why do we want to script with IDAPython? Primary reason is to save time. If you do reverse engineering, like I do, and you've been doing it for any length of time, the first thing you realize is that the most expensive part of reverse engineering is time. There's nothing that anybody can stop you from reversing completely, but they can slow you way down, and that's where the scripting comes in handy with IDA. So a couple of things real quick too is you need to know how to use basic IDA. If you don't know how to use basic IDA at all, this is not the video for you. Go watch a different video and come back later when you're ready to actually do some IDAPython programming scripting. So my approach for this is, instead of trying to just give you a whole bunch of generic information about scripting, we're just going to actually look at a problem and then solve it with a script. And that way you can learn some of the most common IDAPython APIs, how to use them, and how to specifically apply them to solving an actual problem, rather than just me reading off a whole bunch of them, which you can actually look at because I'm going to post stuff in the description. And which reminds me, do look at the description. I'm going to post a lot of links there. I'm not going to explain everything I'm going to post there in this video, but I'm going to post a lot of links there that are going to be very, very helpful. Trust me, because IDAPython is one of those things where it's not super easy to find all these resources online. It would take you probably a week or two of searching and talking to people. So having them all in one little area is going to be very beneficial. All right, so the agenda here is I'm going to present the project to you, or the problem, so to speak. I'm going to present the API functions from the IDAPython library that we're going to use to solve the problem, and then I'm going to present the actual solution or the implementation. So the project is find out if there is a function which contains the string start, and if so, print out all of its assembly instructions. And there's actually a bonus component, which you'll see here as well. So we need to break this down into steps, right? So this is how I generally approach a programming problem in general. I don't know if you do it this way, but this is how I do it. It just helps me to break the problem down into little subproblems. So first thing we need to do is search the function list for start, right? So if you've had any experience at all programming with APIs, then you are probably already conjuring up an idea in your head where it's like, okay, you know the names window from IDA Pro. We need to actually look through the names or the functions windows and look for a function called start. So then we need to, once that's found, we need to get the address of it. Then we need to go to the address. Then we need to locate the end address of the function, or else we're just going to keep printing instructions forever until the end of the file. And then we need to print each instruction between the two addresses, right? So in other words, we need to find the beginning of the function, the end of the function, and then print each address in between those two addresses. And I just want to go over that real quick, that IDA Pro sees a lot of things as addresses, and that's sort of like the basis in how you're going to be operating. In other words, you're going to be, the main function argument that you're going to be passing into most of the API functions is going to be a memory address. And that address in the IDA Pro library is called EA, or EA, which I'm going to show you in a second. So, and then there's a bonus here that we're going to do as part of this implementation, just to show a couple other APIs, which is if there is a call after a jump in the function somewhere, we're going to annotate or comment that line. Okay, so you can look this up yourself, but I did want to show this real quick. If you Google IDAPython API, this is what's going to pop up as the first result, basically. And it's nice in that this page has like all of the functions, or most of the functions on it, so you could hit Control F and search for something like get underscore, and then you have sort of a list of things to pick from here. But I just wanted to highlight that the most commonly used functions that you're going to be using are going to be in IDA API IDAutils and an IDC module. So this is, for example, the IDC module, some of the functions there. But you could basically click one of these, or you could go, there's a everything option up here, and then you could just hit Control F, and you could try to search the documentation yourself that way. Now, the documentation, it has a lot of good, useful stuff in it, but there are a couple of caveats to it which make it kind of difficult to learn. And one of those caveats is that, for whatever reason, I think they've changed some of the names, and so you will see a lot of the functions, which I'll show you some in the implementation, will have no underscore in between them, and they'll be using capitals, and then the actual documentation for it in the API documentation is using an underscore in between the two words, and it's all lowercase. And I'm not sure if it's because the uppercase without the underscores is the old API, and they just have kept that to not break things, or what it is, but that can be kind of a hassle. So just know that. And the other thing too is some of the functions aren't even in the docs at all, and you actually have to. They're inside of something called the Pro SDK, which is like their software development kit, which is like a C++ thing. So yeah, it's a little bit of a pain. So instead of ramble on about that, though, I put together my own list of useful functions that I mostly use, and I'm going to give you that list on a pastebin. So here we go. So we're going to talk about the functions needed real quick. So again, most of these are going to be in IDAC, IDAutils, or IDAPI, and you can feel free to import those on the top of your scripts. I just put the names here to make things really clear as to which library each one of these functions is coming from. So we're going to use IDAutils.names, just like that, with a capital N. It's going to return to us a tuple of all the names from the names window. So here, let me go ahead real quick. Here we go. So this window in IDA Pro is the names window, and we're just going to get basically a list of tuples, and each tuple will have the string name and then which address it's at in the file, basically. So I'm going to go back real quick, and then what we're then going to do is get the function at the address, and we're going to store the function structure inside of the myfunc variable, and then myfunc.endEA, like I was telling you, endEA is going to get the last address in the function. Now remember, this is a property. This is not a function, so there's no parentheses there. It's just once we have a function object, we are then accessing the last address, because when we create a function object, IDA figures out where the end of the function is, basically. So we're going to use that, and then we're going to use IDC get disassem. This gets the instruction. It returns a string of the current assembly instruction for the current line that we're at, whatever we pass in here. Again, this is going to be a memory address of the actual line that we're on. And then idc.get idc.get or get mnemonic is going to get you the operation, basically. So call, jump, move, etc. of the address that you specify in here. idc.prevhead and idc.nextHead. Okay, so this is another thing that they do in IDA. So basically, each instruction or data component that IDA parses is referred to as a head. So if we're saying get next head, what we're saying is get the next instruction. Now, you have to think about this for a second, because the next instruction is not necessarily the next address. So if we're at address 0055AA11 and we say get next head, it might not be 0055AA12. It might be 0055AA20 or something like that. So just know that. And that's the reason why we say next head rather than just increment the address by one, by one. So that's important to know. And then idc.makeCom. This is what I was talking about here. So see the difference here? See how we have prev underscore head, and then here we don't have an underscore, and then we have these caps like this. So these both work in my experience. In fact, when I run these, I usually hit Alt F7 inside of IDA Pro, and so I don't even have to import the libraries. They're already imported on my IDA, but you may have to import IDC and IDA utils and IDA API. So just keep that in mind. Or you may not. But in any event, these all just work for me by default when I load the script. So, but again, I think this might be from the older version of the API, or these might just be macros or something. I'm not 100% sure, but what I will do is I'll give you links to use these, because these are kind of easy functions to remember and use. So I'll give you links to all of these, and then I'll give you links to the API where it has the documentation for where they're in this style like this. Okay, so now I'm going to explain the actual code to you and show you the implementation here. So first part, got to plug the creator, right? No, I'm just kidding. So the reason why I do this print statement usually at the beginning and then I do one at the end is because in the window, the console box, I just want to know where the program has started and then where it's concluded. And it'll make more sense when you actually see the output. So we're going to create a variable called cursor. This is going to represent where we are in the program, which memory address we're currently at. We're going to have one called a list called real names, a list called addresses, and then this is going to be our list of named tuples that I talked about previously. And then what we're going to do here is, so because names returns a list of tuples, you're going to have to get the names and addresses out separately. So that's what this does. So we iterate through every single tuple, and we take each address, which is the first element in the tuple, or the 0th element in the tuple, and we add it into the address list, and then we add the name, which is the first index 1 element in the tuple, which is actually the second item in the tuple for each one, and we add it to the real names list. So what we've done is we've split this tuple into two separate lists, and one list contains the address and the other one contains the name. And it's important to note that since we're going to get a complete tuple back for every single one, whichever index we are in the name, the address for that name will be in that same index of the addresses list. So now I say for real name in real names, which is where the names are stored. That's the list of all the strings. If the name equals start, then we're going to take the address index position of that element inside of the real names list. So we're gonna go and we're gonna find the name start in the names list. We're gonna get the index of that string in the names list, and then we're going to put that index into the addresses list and get the address from that addresses list, and then finally we're going to store that address in cursor. So that essentially points us to that address. And then I already showed you the names window earlier. And then print and comment. So this is the second half of the script. So now we're saying if cursor. So we're checking to make sure that we even found the start. If we didn't find the start, we're not going to do any of this. So cursor will be 0, and then this if check will not be satisfied. And therefore it will skip and it will just end the program. However, if we did find the cursor, there will be a memory address here and it won't be 0, and therefore we will continue on. So the first thing we do is we have to basically parse the function. So IDAPro allows you to use this API call called IDAPy.getFunc, and then you specify an address. And if this address is inside of a function, then IDAPro will figure out which function it's part of, and it will have basically a function object, and then we're storing that function object, which gets returned in myfunc, and that allows us to access certain properties and methods. So then we basically say while our current position is less than myfunc.endEA. So what this is saying is while we are not at the end of this function, for each instruction in this function, we're going to print it out. So print idc.getDisAssem cursor. So we're going to take whatever current address we're on for the current instruction, and we're going to feed it into getDisAssem. It's going to go fetch the assembly instruction line. So in other words, this is not just like the operands or the operator, it's the entire line of the instruction. And then we're going to print that out. And then we're going to say if the operator of this current instruction is a call, and if the mnemonic of the previous instruction is a jump. So if the operator of the current instruction is a call and the operator of the previous instruction is a jump, then we're going to make a comment on the current instruction which says this is a call after a jump. So does this make sense to everybody? Get as I said earlier, gives you the operator, and it just returns it as a string. So we're saying if the operator of the current instruction is a call, and the operator of idc.prevhead. So we're feeding in the current address that we're at right now to the previous head function, and the previous head function gets the previous instruction before the address that we're at right now. And then we're then getting the operator of that, and we're checking to see if it's a jump. If it is a jump, and the current operator is a call, then and only then are we going to print out a comment, and we're going to put the comment on the current line, and it's going to say this is a call after a jump. So even this IDC make com API is very simple, very straightforward. You just give it the address of where you want to put the comment, and then the text of the comment here. And then finally, this is like enumerating through a linked list basically here. We're going to say where we are currently. So our cursor is now equal to the next instruction. So we're moving on, and then we're going to loop back around, and then we're going to do everything again, and then we're going to loop back around, and then we're going to move on, and we're going to loop back around, and we're going to move on until finally cursor is no longer less than the end of the function. So if you've ever studied or written any linked lists, this should make a lot of sense to you. If not, then you might want to check out what a linked list is. And then finally, like I said before, we're going to print out the end of the function or the end of the script, so that way we know it's done. So that's it for the program, and I hope this really shows you some APIs with IDAPro and how to use them. Now, this is the output of it. I realize here that it might be a little bit hard to see, but basically what we did here is it printed out, it found the start function from the function name list. It would be equivalent to hitting Control F and typing it in, getting the address, and then it printed out all the instructions from the function, and then it capped it off right here with the end message. So that's again why I wanted to show you why I like to use an end message, because sometimes there's a whole bunch of other junk in my console box from previous scripts or from the output of IDA, and it's hard to see where my script started and where it ended. And then kind of hard to see, but right here is the highlighted the comment that we made. So it found that there was a call before a jump, as you can see right here, and it went ahead and placed the comment on that line right there. So the script executed successfully, and that's what I want to show you. Okay, so real quick, I want to talk about how I could have done this better. So I don't know if you noticed, but I used the names list. But after the fact, I'm probably going to refactor that and make it use the functions list instead, because right now names could include functions, but it could also include other things that are not functions that are in the binary. And the problem with that is we don't want that. We want specifically functions. So what I could have done is enumerated functions instead of names by using the API IDAutils.functions instead of IDAutils.names. And then I could have used idc.getFuncName with the address in order to get the function name and then test that for start rather than the name string for start. And then this would have prevented getting non-function items, like I said. And then also, I'm going to clean the code up a little bit, and then I'm going to put it in a pastebin. So, for example, I'm probably going to use like a macro for the name of the function that we're looking for. So that way you can just go ahead and plug in whatever function you want to look for, and the script will do that rather than making it specifically hard-coded to look for the start function. So that's it. If you have any questions, feel free to send me a tweet at this right here, MovieAX41H. Sign up on malwareanalysisforums.com to discuss. And if you have a better way to do this, feel free to drop suggestions in the comments. I love learning new ways and more efficient ways of doing things in code. So, and by no means that I'm an expert at this at all. In fact, I consider myself to be a very weak Python programmer. And one of the reasons why is because I mostly do C. So I think of everything in a C way. And so, like, I get easily confused by some of the higher level constructs, and I try to avoid them, actually. I know it's kind of crazy because it's like backwards for most people, but anyway, feel free to drop me some suggestions, and also please don't forget to subscribe. I hope this really helped you guys and gals, and also I wanted to drop a shout out to the OA Labs channel. Those guys are super awesome, Sean and Sergey, and they're always putting up really cool IDA Pro content as well, and so I want you to go ahead and check out their channel if you want to learn some more advanced IDA Pro stuff, especially when it comes to reverse engineering and unpacking files and malware analysis and stuff. So they've been a real help to me, and they're also a source of motivation. So I really want to drop a shout out to those guys, and until next time,